So the text we're going to wind up using now, the old one is still out there. It's under extra text, but we're going to use this one, textbook 2, called Python Programming from Wikibooks. And then we have a doc version if you'd like to open it up in Word or a PDF. Either way, since it's a long document, you're going to want to download it. So, of course, I'm going to scroll past all the huge things. If you need help installing Python, they try to give you some hints. But I think everybody's already done that. They list a whole bunch of Python editors. I just recommend using idle, not installing anything extra. We did talk about the interactive mode, which is what the Python shell is. So as soon as you launch idle, or if you pop open a command prompt instead, if you type C and D into the start box and bring this up, then if you type Python in, it brings the shell up right inside what people used to call the DOS prompt, but it's not really DOS prompt. It's the command prompt. Now this isn't idle. We can't do a file new and create a script this way, but it is the Python shell. You can go ahead and execute commands directly into it. So here I am in my Python shell. What I did to get to it, I went over here, I typed CMD into the start, I launched it, then I typed Python, and as long as Python is in your search path, it should pop it open like that. So you could do things like n is equal to hello, and then tell it n times 3, and it's going to say hello, hello, hello. That kind of stuff. But really, we're going to spend the vast majority of our time writing scripts rather than typing immediate commands. So I'm going to close those. Typically, the first program anybody ever writes in any language, I don't know who made this up, I'd like to see the first occurrence of hello world in a manual. Probably the C programming manual written in 1971. I bet that's the first time. So this is walking you through creating a folder on your Mac or on Linux, opening a file, doing a save as, and then running it. We already know how to do all of that. Wow, you have to do a lot of stuff under Linux, supposedly. You have to do chmod, change the mode of the file to make sure that Linux knows that it's an executable program. Yeah, okay. Y'all Linux gods, you scare me. So Python is an object-oriented language, and just about everything in it is an object, even raw numbers. And what do I mean by that? I'm going to launch idle, and then if I type s is equal to, I'm doing this in the shell, not in a new file, s is equal to Bob, and then I type in, I'm not sure what I'm going to type in after the decimal point. Yeah, s dot, sometimes idle is useful and pops up this little helpful, IntelliSense thing of commands you can type. It's rarely there. But type s dot upper, parentheses, into parentheses, and it prints the uppercase version of Bob. That's because this is a string, and a string is a class, meaning that it contains both data, or at least it can contain, both data and then functions, in object-oriented terms known as methods, but we will call them functions for the most part, that are attached to that data. So the data is the word Bob, the characters, the sequence Bob, but then it's got a method that will print the uppercase version of it. If we want to print the lowercase version of it, we could type s.lower, parentheses in parentheses. Now surprise, we're back to the lowercase. Did that change the original value of Bob when we did s.upper, parentheses in parentheses? I'm going to find out. I'm going to just type in s and hit return. No, it's still lowercase. If I wanted to convert it to uppercase, I would do s is equal to s.upper. What that does is it calls the upper function and then stores the result back into S. Where have we seen a similar syntax? When we're not quite like this, but something rather similar to that. When were we doing something like that? Yeah, for our input. We were doing something like x is equal to int parentheses x. Or we did x is equal to input and we typed in, a string that we wanted to be displayed on the screen. Same idea. This is a function, but the function acts upon the data that is stored in that variable. Now here's what's weird about this language that you can't do in everything else, all other languages. Type this in, quote, hello, or some word in quotes, close the quotes, and then type dot, and then type upper. That's pretty wild. Even data. In a programming window, these are known as literals. Literal is what you literally type into the code. Either like a number, 1, 2, 3, 4, 5, or a string, like the word hello. Even literals in Python are objects, and that's not true of most languages. You couldn't get away with trying to get that to happen in Java or C++ or something like that. So one thing we need to talk about is scope. Scopes are regions of code. Now we do need to go ahead and open up a new file. So click File, New File. Do a save as. Save it to your favorite scripting directory. Desktop, scripting for mine. I'm just going to call this one Jan25.py because I'm not feeling real creative. So I'm going to type something in like a is equal to 10. Then I'm going to do an if based on that value. If a is equal to 10, colon, print hello. And then I'm going to say b is equal to 5. Then I'm going to stop tabbing and I'm going to do print b. And this is an error. This is not going to run. It might be clearer why it's not going to run if we were writing in another language that supported the curly braces. Don't add these because this doesn't work in Python. But if we had these curly braces here, can you guess why B is not available to be printed here? Yeah, it's defined in this block. It's defined in this code block that's subordinate to the if statement. B only exists until we stop indenting the code. Or if you're using a language that uses curly braces within the scope of the curly braces. So the scope of the variable is its lifetime. This guy expires, the poor thing, when we stop indenting the code. So let me prove that though. I'm going to take those two things out and try to run it, and I should get an error. Yeah, did it just work?
Yeah.
Because it is true. Changed it A up here to 11. You're smart. You're smarter than the teacher. Okay. And then we do get the system error. Which looks like this. It's a red error and it tells us what line number the error was on. Line number 8, we could tell what that was because there's a line number counter in the bottom corner even if you can't see it. That is line number 8. Okay, it kind of blows my mind that that actually worked because in other languages, B would not exist after you stop tabbing. In this language, hey, no problem. I guess I defined B. You can keep using it until the end of the program. But you have to be careful. If I wanted this to work, I need to initialize B with some other value, way up here where I initialized A, so that it existed regardless of whether A equaled 10 or not. That would be one way to fix it. I could do this. I could add this, b is equal to 0, and then when I ran it, if a equaled 10, it would set b equal to 5, but if a did not equal to 10, it would print out 0. That's one way to do it. But for those of y'all who've seen the else statement, is there another way to do it? I could take that out and I could still get it to work by rewriting this code up here. Who remembers else's? What would the syntax for else be? It's ELS colon b is equal to 0. So if you look at the logic, if a is equal to 10, set b equal to 5. But if a is not equal to 10, set b is equal to 0. Now it's going to do the same thing that it did when I was initializing it up there. Is one way better than the other? Not really. I can't say why I would prefer one way or the other in this language. In any other language, I would say go ahead and set the b equals to 0 up here and don't use an else clause. Then there is something known as a namespace. A namespace declares a set of space within which in your program that data is only available to it there. And it works similar to the way you define functions. If you haven't seen Python, you certainly are not used to defining functions, but I'm going to go ahead and do this. I'm going to define this code up in a function, and I'm going to call it, I don't know, sample. And then everything after it needs to be indented. Then down here, I'm going to call sample, and then I'm going to try to print b out, or a out. And in that case, it behaved as a computer scientist would expect it. B is not defined here because when we called the sample function, it went up here, it ran all of this code, but then when it returned out of this function, when it hit the first non-indented line and it came back to here, B no longer exists. It is no longer in scope. When you're writing a function like this, you can stick the word return down here at the bottom to give you a clue to visually key in on where the function ends, but you don't have to. The function ends at the first non-indented code. So in this language, unlike other languages, the namespace is defined by the function in which it's in. In other languages, there's a keyword called namespace, which you use instead of def. We're going to do something which is dumb. Maybe I'm going to skip the concept of namespaces above and beyond that. You get the idea, though. Anything defined within the function is only available within the function. What if you wanted to use that value down here, though? You can do that using what's known as a global variable. And this is what I did earlier. I defined the variable before I used it. I can come up here and do b is equal to 0. I'm going to set it b is equal to 1. And when I run it, it's going to be curious to see whether b is equal to 1 or 5 or 0 by the time it ends? Well, A is not equal to 10, so we are kind of hoping to see it say 0. Howsoever, it says it's 1. Even though it printed it out here and it printed it out as 0. The reason why is that if you want to use a variable that's defined outside of the function, you have to tag it with the word global. So up at the top of your function, add global space B. What this does is it says, oh, by the way, I'm going to be using a variable that's not defined within me. But any changes I make to that variable, I want you to continue to keep in your memory. So that way, when we set B either equal to 5 or to 0, that change actually exists down here. And so it printed out 0 both times. Who has not seen functions before? Feel free to raise your hand. No one's raising your hand. Cool. Alrighty. So you have the idea. If I write this series of functions, you don't have to type this in, but if I do this, define Fred, print 1, and then Wilma, and then here I do define Wilma, and I print 2. I don't know why I'm putting the numbers in quotes. It would print just as fine either way. And then down here I call Fred. What is it going to print?
It's just going to print 1.
It's going to print 1, and then what's going to happen?
It's going to look for 1, but since you didn't define it before you called it, it's not going to run, right?
It actually is going to run. You have a very good point, but in fact, your point may be so good you may be absolutely correct. Yep.
Oh, no, you didn't
I forgot the colon. I forgot the colon. Let's fix that. I did not mean to close. Anytime you start indenting, you have to have a colon on the line previous to it. Alrighty, here we go. Run. That is what it printed, 1 and 2. So, the thing is the reason it worked, even though Wilma was not defined before Fred, is because it went all the way down here before it started launching any of them. And by the time it gets to this line, Wilma is defined.
Okay, so if you put Fred before Wilma, then it wouldn't.
Exactly. If I went and I put Fred here, well, after the print, but it's not going to work. So the Java language is not order dependent like that. You can put your functions in any order that you want. The C and the C++ language are. If you look at what's going on here, it can't invoke Fred because Fred hasn't been defined yet. So I think to myself, oh, okay, I'm going to cut and paste and move Fred up there. It's still not going to work. Why? Because Wilma is not defined yet. So what it's going to do is, while it's running, every time it hits a DEF statement, it goes ahead and defines that function, but it doesn't execute it. It looks for the first non-indented thing to run, and in that case, the first non-indented thing is the call to Fred. So it would pop up here. It would print out 1. Then it's going to try to invoke Wilma. Unfortunately, Wilma has not ever been defined. It doesn't know about it yet. I would have to move that up as well. And as long as I put it above Fred, either above or below that function, it's going to work. So I want to reiterate that. If I have this, DEF wowzers, and I print wow, and I put that up at the top of my code, is it ever going to print wow?
No, because you didn't call it.
Because I never call it, right. It just doesn't get invoked. A lot of code that you will see coming up in my class looks like this. DEF main. And then you put all your code in here. Wow, this is cool. But that means that somewhere down at the bottom, we actually have a call to main. The syntax for the way that looks is a little bit odd. Let me get it absolutely correct.
Is this what we need? Do we need to start typing now?
Yeah, let's create a new file. Do new file and call it, do a save as and call it Jan25b, just because that other one's getting too messed up. Jan25b. So here we're going to put some kind of code, def main, parentheses in parentheses colon, print hello world. And then down underneath it, we're going to have an if statement. And when I put these underscores down, these are 3 underscores in a row. 1, 2, 3. Name, 1, 2, 3. Equals equals. Quote, 1, 2, 3. Main, 1, 2, 3. Quote. Then call main. This looks odd, but there's a very good reason for doing it this way.
What's the purpose of the 3 underscores?
Well, let's run it and make sure it works. I'll answer your question, but it's going to take me a minute. Name is not defined. Was it just 2 underscores? Am I wrong about that? All right, change those 3 underscores to 2. That was my mistake. Why do we do that? Okay, make yet another file. Do new file, save as, save it in the same directory, and call it mommy.py. And then do print, I want my mommy. Save that and then go back over here. At the top of this code, above that main, do import mommy.py. Maybe it's just import mommy. Look what it did. It brought the other file in, and it ran the code in it immediately. Usually when you have an import statement, you don't want it to execute stuff. You just want it to get ready. So for y'all who took the last class and used the turtles, and we had import turtle, we didn't want that import turtle command to automatically put a turtle on the screen. We just wanted to get it ready for using our turtle. So having it pop up and print I want my mommy every time somebody did an import mommy is not too cool. We would want to put that in a function. So go back to mommy and do def hi mom. And then tab that print over 1. Save that and then go back to the one that had the import mommy up at the top and run it. It will no longer say, I want my mommy. It is a better behaved piece of code now. You never want code that actually starts printing stuff on the screen and starts running just because you issued an import statement. That'd be like just because you brought a book home from the library, you know, it starts casting spells and summoning dragons or whatever. You want to wait until you open the book and start reading that stuff before anything happens. The same is true as with this. underneath that import mommy, if you've gotten that far, I don't want to go too fast. Has everybody got this far? Add this line. Mommy dot hi mom, parentheses in parentheses. We're going to be back to printing I want my mommy. We imported the function, the mommy code, the mommy script, and then we were able to invoke that function. Mommy.highmom. But now we have a bit of a puzzle. What if we were over here and we wanted it to print I want my mommy? What if we want this code to run if we're in this window, but not to automatically run when they're in this window? I'm going to comment this out for now. I would like to be able to come over here and do run module and have it print I want my mommy. Whereas if I'm over here and I do import mommy, I don't want it to print I want my mommy. Unfortunately, it's doing both. It's neither one of them's printing right now. And that's what that if statement's for. So here, come down here on the hi mom one and do if underscore underscore name underscore underscore is equal to quote underscore underscore main underscore underscore invoke hi mom. So just tab hi mom. And I forgot the colon in after the if statement. There we go. So now when I run it in this window, it does print hi mommy. Or I want my mommy. That's good behavior. That's what I said that I wanted. But if I go over here and I type import mommy, it doesn't run it. Unless I then call the function, which I commented out. So that is a well-defined script. That is a well-behaved script. If you run it from the window in which it's defined, it goes ahead and does the function. But if you import it, it doesn't do the function. So what is this code actually doing? This is a variable that gets defined to let Python know what module it's currently in. Come up here and do print underscore name on the mommy code. Underscore underscore name. And then do run. I put a space there. That broke it. Don't put the space. 2 underscores, no spaces. It says that the name of the area that we are currently running in, of the code that we're running in, is main. If we go over here to this one, the one that has import mommy, and we do run, then it says that the name of the code that we're currently running in is mommy. So this variable here gets either filled in with the word main if it's the one that's currently running, it says main again, or it gets filled in with the name of the program itself if you come and do import. So when I run it over here, it's not going to say main. Instead, it's just going to say the name of the file. So this business is, what it says is if you're importing this file, don't run this stuff. When you're importing this file, underscore underscore name is not going to equal that. But if you run it in this window, if I go and do file run here, then underscore underscore name does equal that, and it will invoke it. So you do that when you're building projects with more than one file. So you're going to see me have, or I'm going to have you type this a lot. If underscore underscore name is equal to underscore underscore main. Just get used to typing that. Another reason to do that is that will load all the functions that we defined in memory before any of them run. Just like we did with Fred and Wilma to make sure that they were all in memory. We put our call down there at the bottom. There are other variables we can use. That's the most important one. So data types. We've talked about data types. What are ints?
Whole numbers.
They are whole numbers. Longs don't exist in Python 3. In other languages, they are larger whole numbers. But in Python 3, ints are longs. They hold great big numbers. Floats
Decimal.
are useful for decimal numbers. And then there's complex.
Imaginary.
Is that correct? We never used them.
Yeah, how would you use complex?
I don't think we are going to use them.
How would you use
Complex.
complex once without it in the Python class? Complex at all.
See pi down there.
Yeah, it is for real and imaginary numbers. So a complex number has two pieces in it, a real number and an imaginary number. And unless we have a strong reason to do that, we're not going to talk about it. There's a CMath library, which gives us some functions, like to calculate the exponent, e to the power of x. We're not going to do that. The logarithmic value of something, the 10-base logarithm of something, the square root. Now that one's actually useful. So go back to the code that had import mommy up at the top of it. And underneath main, let's try to print the square root of 100. Print cmath.sqrt 100. I'm not expecting this to work because we have not imported the CMath library. So up here above or import mommy, we also have to do import CMath. Now when we do it, it prints out 10 plus 0j, which is absolutely not what I was expecting from the square root. Oh, because CMath is a complex math library. Take the C out of both of those. We just want math. Do import math and then import math and then print math.square root. That makes a little more sense. And there are a lot of functions in the math library, sine, cosine, tangent, all that kind of stuff. Yes, sir.
Mine's not doing any sort of math.
Okay. So let's repeat that. Okay, let's print a few more things. Print math.ceil of 2.5 or 2.9, 2.8, whatever. And then print math.floor of 2.8. And then we're going to print math.round of 2.8. Now 2.8 is above 2.5, so it ought to round it up. So when we run this, we ought to get 3, because if you take the ceiling of a partial number, it rounds it up to the next whole integer. Then it'll print a 2, because floor causes it to round down. And then the round function causes it to round it to the nearest integer, which in this case is 3. So it's going to print 323. Or there is no attribute round. Let's go back and see what I did wrong.
It's the parentheses.
Is there no round function? Well, paint me yellow and call me a taxi. Is that it? It's just a built-in function.
Yeah, that's,
It asks for a number and then the decimal place.
Okay. Thank you for reminding me.
Yeah.
Delete this last line and just make it round. And let's make it round 1.3333. Whole bunch of threes. That's going to be 1. But if you specify a number of decimal places, round 1.33333, comma 1, and then do the same thing except round it to 2. So the default is to round it to no decimals. Then if we specify we want it rounded to 1 decimal, we got 1.3. When we said we want to round it to 2 decimals, we got 1.33. So go back to idle now. And we're just kind of doing a grab bag running around to all sorts of things at this point. Go to the Python shell and type this in. A is equal to parentheses, not parentheses, excuse me, square bracket, 1, comma 2, comma 3, and then close square bracket, and then print A. That's a list. There are other kinds of things besides lists. There's something called a tuple. A tuple is an unordered set. You define those like this. B is equal to parentheses, 1, comma 2, comma 3, and then print B. It will look similar, but there are times when you can't do the same thing with B as you can with A. A is a list, so we can get the elements out by their index number. Type print A square bracket 0 in square bracket and hit enter. You'll see that it prints 1 because 1 is the first item in A. And since we start counting at 0, 0, 1, 2. Try to do the same thing with B though. Print B square brackets 0. Ew, and it does the same thing. Okay, forget what I was talking about. I apologize. Sometimes my brain gets cross-wired from Java. Okay. We don't care about complex types. Strings. A string is a series of 0 or more characters. Strings, you can access the individual letters out of them, or you can access sequences of values out of them. So, still staying in the shell, do this. In is equal to, and then type in a name that's at least 4 letters long. Quote, Jeff, quote. And then type in square bracket 0. It prints a J in my case. Bless you. And then in sub 1 will be an E. In sub 2 will be an F. In sub 3 will be another F in my case because it was 4 letters long. If I try to print out in sub 4, I'm going to get an arrow.
So
Arrow
even if you
and
don't
arrow.
store it into a list, you can still bring it out by its without it being in a list like that.
Right. A string is treated as though it were a list of characters.
Okay.
Okay. Write a program that displays the dimensions of a letter size sheet of paper in millimeters, and it tells us how many millimeters per inch there are. Use constants and comments in our program. Okay, so we're going to know that the height of the paper is 8.5 and the width of the paper is 11. And then we're going to want to run those through a conversion to turn them into millimeters. Since it's 2.54 millimeters per inch, we can just multiply the number of inches by that number and we will get the millimeters. So we've had homework assignments 0 and 1, correct? This will be homework 2. So create a new idle document. I'm just going to close all these other ones. File new. Call this one homework 2 HW2. Don't save it in the Python directory as I was just about to. Okay, I'm going to start it off and then I want you to take a stab at it. Height is equal to 8.5. Width is equal to 11. Then down here at the bottom, I'm going to put print the height in millimeters is, comma, h, and then print the height, the width in millimeters is, comma, width. Now what goes between those two chunks of code in order to actually convert these? Remembering our ratio of 25.4 millimeters per inch. Alright, so somebody help me out. What am I going to do here? I want to change h so that it represents millimeters rather than inches. What am I going to do? I'm going to multiply it by the conversion factor. So h is equal to h times 8.5.
But when you want to do that,
No, not 8.5. Where did that come from? 25.4.
when you want to do that after the print statement, because isn't it supposed to be displayed in? Oh, never mind. Sorry.
Right, right.
Gotcha.
If I was going to display it in inches first, I would wait to do the conversion until afterwards. And it could be that I should have put the converted versions in a different set of variables. I think I will do that. I'm going to say height in millimeters, HMM is equal to that, and width in millimeters, WMM is equal to that, but I'm going to have to go and modify my print statements to match. Why do that? Well, why destroy our original data? May as well keep that. Here's a nasty occurrence of rounding error. When you multiply something by 25.4, you shouldn't get an answer with a whole bunch of 9s. But we're going to live with that.
Did we need to set it to a float someplace?
Pardon me?
Didn't we need to set it to a float someplace?
This already is a float.
So it automatically recognizes it and sets it.
Exactly. The reason we were having to convert the other ones is that when we use the input command, it came in this format. It had quotes around it. And then we had to convert it to a float.
Okay.
So did it take 11 as an int and then convert it to a float later on?
It converted it to a float right here when we multiplied it by a float.
Okay.
If you have a multiply or an addition or something like that, and you have two dissimilar types, an int and a float, one gets converted to the other format, and it converts it to the more complex type. An int will get converted to a float so that it can do that math. So this result was a float. Very good question.
So you don't want us to round it, that HMM?
Yeah, let's round it. This one came out to what? To just point to 1 decimal place? Let's round WMM to 1 decimal place because it looks ugly. WMM is equal to rounding WMM, comma 1 to 1 decimal place. Oh, I should have done height. My mistakes. HMM, well, I can do both, you know, whatever. HMM is equal to round HMM, comma 1. Now they really should be the same. There we go. Much better. Okay, next, write a program that computes and displays the perimeter in inches of the paper and then the length of its diagonal. The perimeter is easy. The diagonal, you have to remember the Pythagorean theorem. So let's work on the perimeter first. If it's 8.5 by 11, let's pretend that this window is 8.5 by 11. The perimeter is the distance along the outside of it. How do I calculate that?
H squared plus
$8
U squared.
You're right, you're not going to square it though. It's h plus width plus h plus width. So you
Right.
could call it 2h plus 2 width. So let's do that. Perimeter, perim is equal to, you could either type this h plus width plus h plus width. I'd rather do it this way. Don't do it both ways though, that's silly. Is equal to 2 times h plus width, that's the second way. Or you could do it this third way. You pick which one you like. 2 times h plus 2 times width. And then print out. Pardon me?
Automatically does the order of operation.
Yes, yes, yes. Because multiplication has a higher precedence.
Do we want it in
The same.
millimeters or H?
The problem didn't specify, so I use the original values. And so I'm just going to print out that this is in inches.
I got an object is not open.
Ew. I've got an error here. I forgot a plus sign. That's what I get for typing it 3 ways. Alrighty. Let me wander around and make sure we've all... Who remembers the Pythagorean theorem? Yeah, it's x squared plus...
A squared plus B squared.
Yeah, yeah. It's the diagonal is equal to the square root of the squares, like this. Why don't we get a picture of it up first? There we go. A, B, and C. A squared plus B squared is equal to C squared. So if A squared is equal to, and don't type this because this is not going to be valid, or A squared plus B squared, we're going to have to solve for C, is equal to C squared. But we want to get C not to be squared because we just want to solve for C. What are we going to have to do?
I guess store it in C and then do C
then square root it. Right, right. You're going to have to square root c, because we have x squared, or a squared plus b squared is equal to c squared. So when you want to solve for c, you take that off and you do that.
Right.
So we can do that. Let's just calculate the squares first and then take the square root of it. We could do it all in one shebang, but it makes the thing look more complicated. So c squared is equal to h to the power of 2 plus w to the power of 2. But now we need to take the square root of it. There's more than one way you could take the square root of something, to be honest. As long as you have an exponent function, this is just kind of a mathematical trick, but if you did this, c is equal to c to the power of 0.5, that's the exact same thing as taking the square root. You don't need to use math.square root as long as you have an exponent. But that looks nasty, doesn't it? If you're not familiar with that trick. Let's try math.sqrt. See, like that.
We gotta import it.
I think I'm going to find out that we did not even have to put math in front of there. Yeah, okay, so let's add the import math up at the very top. Okay, good. It didn't break. So we're good here. Now we can print out the diagonal. And this is still in inches because h and w are still in inches. I'm going to go ahead and scroll. Just remember you had to add import math up at the top, because I know that when the writing gets too close to the bottom of the screen, it's hard.
Yeah.
Okay, again, that's nasty. Add some code that'll round that to 1 decimal place. Where are you gonna add that?
Right after c squared.
Yep, right there. So somebody tell me what I'm going to type. C is equal to round parentheses C comma.
2.
Yeah, that would
You
give me
could put
2
it in
decimal
the
places.
print Also, in the line with print.
I could have done it right there. You're right. I could have just done it there. That would actually be preferable because I would not be destroying the data. I would not be modifying the data.
Right. So instead,
So I'm going to undo that statement after having made y'all type it. And I'm going to come over here and I'm going to do it here instead. Round C comma 2. Bless you.
oh, because it was 0.
I'm kind of confused. I guess. Well, what was it before we did that?
13.901.
Okay, that's why, because it was 0 and it decided not to display it. All right. We'll live with that. Okay, let's make a homework assignment. You're going, yay, I wanted one. So what I want you to do is this going to be similar to this. Calculate and display the area of a square of side 5, because I typed 5. I'm sure you can figure out the volume for the square. Calculate and display the volume of a cube of side 5. Then calculate and display the area of a circle with radius 5. And I'll be kind and give you the formula for that. It's pretty easy, of course, but
A square doesn't have 5 sides.
That's not. I think
side length of 5.
Yeah,
Side length of 5. Same one, side length. And cubes don't have side lengths, but they have edge lengths. You know what I mean.
I'm tracking.
Okay, alrighty. And so calculate the area of a circle of radius 5. The formula for a circle's area is pi r squared. Just use 3.14159 for pi times radius squared. And lastly, calculate and display the volume of a sphere with radius 5. And the formula for that is 4 divided by 3 times pi 3.14159. If you want to use math.pi instead, that's totally cool. Times radius cubed. Okay, so that's the assignment, and we'll make it due Tuesday at midnight. Let's make a Dropbox for what we already did, and then let's bail.